Hi and welcome to this Water STEM challenge. My name is Rowan.
My name is Zane and I'm 9 years old.
And today we're going to be investigating which Hot Wheels car is the fastest. And why are we investigating this, Zane?
Just because me and my brother always fall out about which one's quickest.
Yep, so we're going to settle that argument once and for all. So Zane has selected his 10 favourite Hot Wheels cars, which you can see here on the table. Our ramp measured 2.08 metres long. That's quite a tricky number to do sums in your head with. Zane decided to make a note of the length of our ramp on the whiteboard, where he's going to record all of the results of our experiment. After doing some research, Zane found out that speed is the distance travelled per unit of time. In other words, how fast something is moving. For example, something moving very fast, like a train, can cover a large distance in only a short time. Something moving slowly, like a snail slithering, will travel a very short distance in the same amount of time. An object that's not moving at all has zero speed. Since we know the distance of our ramp, 2.08 metres, and we are going to measure the time that it takes for the cars to travel down the ramp using a stopwatch or a timer, Zane also discovered that there's a pretty simple sum that you can do to calculate speed. Here you can see Zane is drawing this sum in a triangle, which is just an easy way to remember it, with distance at the top and speed and time at the bottom. From this, it can be found that speed is equal to distance divided by time. So as long as you know two of the numbers in the triangle, you can always calculate the other one. We're going to use a calculator to calculate speed, but you could also use some software online or an Excel spreadsheet to do this sum for you. We're going to measure our distance in metres and our time in seconds, so our speeds will be metres per second. Next, we decided to weigh all of our cars. Here you can see Zane recording the weights of all of our cars. Okay Zane, so we've set up our ramp, we've measured the ramp, we've weighed our cars. What else do you think might affect the speed that the cars go down the ramp?
How steep the ramp is, or how heavy the car is, which that one that's missing, that is heaviest.
Yeah.
And this one's lightest.
Yeah. So do you think the heavier or the lighter one will go faster?
I think heavier.
You think the heavier one? Okay. And anything else that might affect how fast they go down? Anything about the ramp?
It's about how smooth the ramp is as well, because if there was like any dirt on it, then it'd affect the wheels on the cars.
So the friction on the wheels might slow it down, you think?
Yeah.
Our ramp's quite smooth though, isn't it? So I guess you could try this by putting different surfaces on your ramp.
Yeah.
Or you could sprinkle sand on it to see if that slows them down as well. So what have we got there going on at the top?
The back wheels are at the edge of the ramp with the end of the car sticking just off the ramp.
Okay, and we've also put a stopper at the end of our ramp, haven't we? Because otherwise it's quite hard to measure the end of the time. So, when you're ready?
3, 2, 1, go.
Okay, 1:46. Right, try again.
Is it wheels bent or something?
I'm not sure.
It's not.
Right.
Go. Yeah, wheels are definitely bent.
So we're going to have to eliminate car number 4, yeah? Now that we have all of the times for our cars, which you can see Zane putting onto the whiteboard here, we can do the sum to calculate speed. So you might remember from the triangle earlier that we calculate speed by taking the distance and dividing it by the times to get, in our case, a speed in meters per second. So Zane is just writing all of the times that we calculated for the cars onto the whiteboard now, and you can see he's made sure to indicate the car that we had to eliminate from the competition because it couldn't go in a straight line down the ramp. And now for the final result. You can see that car number 1 came first, car number 6 came second, and car number 3 came third.
Well, the end result was the opposite of what we expected it to be, being the smallest, lightest, unaerodynamic car of 9 cars. 1 got eliminated. It won.
That one was the fastest down the ramp. Okay, and what came second?
Second was this car, which I'd expect to beat that one, but it didn't. And third place was this car, which I'd expect to beat both of them, but it didn't.
Okay, so somewhat unexpected results.
Yeah.
And I think that's just the way things go sometimes with science.
Yeah.
So there's probably a lot more to investigate here, isn't there? What things do you think we could have done to increase the confidence in that result?
We could have tried some of them that we were unsure about, such as this one. We could have tried it multiple times, which we did, and it was still quickest.
Yeah, but you could make multiple measurements to have more confidence in the results. Okay. Anything else? Do you think, if we were thinking about the weight of the cars that we didn't really use at all as part of this experiment or calculation, but I mean, if you were to do it where you were considering the weight, what do you think you might measure differently?
Well, the lighter car definitely went quicker down the ramp compared to this heaviest car, but the heaviest car, we found out that the heavier the car is, the longer distance it goes, but that doesn't necessarily mean it's quicker. But the smaller and lighter the car goes quicker, but it can't travel as far.
Okay, that's really interesting, isn't it? So there's a lot more experiments that can be done here, looking at friction, looking at mass of the car and the forces that are working against the car or for the car to make it go faster or slower or travel further. So we would love to hear from other people if they do different experiments or if they repeat this experiment, and we'd love to see which are their fastest cars or items. Of course, you could use, what could you use instead of cars? Marbles, yeah.
Anything really that can roll down a ramp.
Yeah. So we'll share our results with you. We'll post a graph of our results. We're going to make a graph, aren't we, in Excel? We'll share that, and it will be great to see everybody else's. We hope you've enjoyed this STEM challenge today, and hope to hear from you all soon. Make sure to check out more STEM challenges on the Waters Facebook page.